Hello everyone, welcome to my stream. If you caught my last stream, which was last Wednesday, it was a pretty cool stream because I was finally able to get some decent vectors rendering. So why don't I show that? Hold on a sec, just want to lower the music a bit. Okay. So yeah, I'm just going to start by showing you basically where we left off last week. So if I disable the trace and hit continue, here we can see that in our OpenGL display here, we're actually somewhat rendering vectors into something that kind of looks like this Vectrex screen here. So if we like compare, okay, well now it's changed a little bit because it's showing the next thing, but you can kind of see there's some similarities there, right? So this was pretty exciting for me to hit this milestone of getting the screen to kind of look like this. Now obviously there's a lot of stuff not working here, and I have my suspicions as to what that could be, as to why that could be, I should say. So yeah, so we still have quite a bit of work to do, so let's get started. Before I get started, I just wanted to write down a little to-do list of stuff that I was thinking of maybe working on, because I have a whole bunch of things I like to work on, and I kind of want to put them down and see which ones will get done. So one thing I was thinking is I would really love to just have the ability for the OpenGL window to open on this monitor here rather than on my other monitor, which you don't see on stream. So I'm just gonna do that. So I'd like to, how can I say, support positioning in GL window at input XY or something like that. So Y window position, and it looks like I'm in insert mode. Okay. Apart from that, for the vector drawing, one thing I need to do is finish implementing, or implement anyway, timer 2 for game frame timing. This is basically to get our 50 Hertz. This is going to be imperative to getting the vectors to start drawing properly on screen. Because right now I'm just drawing lines non-stop, and I'm not clearing anything. And so I was thinking about how I want to make sure to clear, or not clear, but basically make lines fade away. Now, ultimately, my goal is, so I just want to check this. I feel like the music's a bit loud. So yeah, my ultimate goal is something like, maybe draw lines into some kind of buffer, I'm thinking, and then like eventually maybe write a shader pixel that manipulates or uses that source buffer to finally draw the on-screen lines, and do it in such a way that there's like, glow and different effects. Still not sure exactly how I'm going to approach that, but for now, the system we have in place where we just add these lines and render them is fine. And I was thinking that what I want to do to sort of simulate the fact that the lines we draw don't remain on screen all the time is something simple, something like draw a black overlay quad at a given opacity based on delta time. So the idea is, like, if we decide that, like basically we want to fade always a screen towards black at a certain rate. So that's why I was going to use the delta time, and we decide like how long it takes for a line to kind of remain on screen. We just kind of play with how long, with this opacity multiplied by delta time. So that's something I'm going to do. And then the idea there is, like, when we have that, we can, you know, delete or clear the line list after drawing them per frame. So we don't keep building this huge buffer of lines, this vector of lines like we do now. We add our lines for the current cycle, and then we draw them, and then we clear it. So we just keep drawing and drawing and drawing, and then we just keep drawing this black overlay, which will make them go eventually back to black. And this will sort of simulate what the Vectrex does to some degree. And I think it'll be good enough for now. Oh yeah, and then I think once we have that, we should have even a better idea of like how things are looking. Hopefully we'll see the animation. I'm hoping to see the animation of the lines, you know, like what we see here, this little animation of the side. I'd love to see that, and even what we see here on Vectrex, maybe we'll see some indication of that. So if we get that far, that'll be great, and then after that it'll be basically working on fixing the drawing, whatever that means, right? So we'll see what that gives. So why don't we start with support positioning OpenGL window at input XY position. So for that, we're going to go to our main here. Actually, maybe not our main. We're going to go to the, I don't know what I called it. What did I call it? Oh yeah, the SDL engine. So somewhere in here, when we create our window, create window. See here we do SDL window position, centered, centered. Instead, we could pass in a proper XY position here, right? And ideally, it's not something I want to hard code, so it's something I'd like to read. So actually, before let's do some tests, right? So let's do like so I'm thinking it's probably 0, 0, because the way it's working right now is I have my primary monitor on this side and my secondary here, and so that's 0, 0. So I'm gonna have to go like negative something. Let's say negative 500. And window Y. I wonder what centered maps to actually. Zero STL position. Oh, I see. Some kind of mask. Okay, well, whatever. For now, we'll just say let's center it like this. Window X and window Y. So let's see what that looks like. Okay, yeah, there we go. So we actually have our window showing here. We need to bump it a little bit further. So let's go like minus 900. Okay, that's pretty good. Okay, so to do this, I'm just going to make a very quick little you know, class, and I'll say options, and I'll say here so actually what I'm going to do is I'm going to say -1. I'll treat -1 as centered for now. do a load options file. We're just going to keep this really dumb, really simple. If we don't find one, that's fine. We'll just return, or yeah, we'll just return if we don't find it. Otherwise, what we'll do is, not even sure how I want to do this. Maybe something like that. Okay, I need to include fstream. Hey Michael C, how's it going? I'm pretty good. How you doing? Thanks for joining. Trying a little file options code. Actually, that's not what I want to do. So I actually have a bunch of parsing code in my debugger. Maybe I'll just see if I can. Yeah, I have this like cute little tokenize here. Oh yeah, that's right, I use split. What am I looking for there? Space and tab? Yeah, that looks pretty good. Maybe what I'll look for is something like equals. I think I need to include my string helpers up here. So if my token size is less than 2, just skip that line. All right, so if tokens of 0 is equal to window X, let's set our, here, let's move options up here. Okay, and now I need my little, what did I do again? I have this cute string to integral here, but this is more for my debugger. Not sure I want this whole thing. I kind of just want this part here. In fact, why didn't I use that? Oh, I see Alvaro's joined. Hey Alvaro, Thanks for joining the stream. Yeah, I don't actually remember why. Why did I go for this again? I could have gone for S to L. Alvaro, I'm going pretty well. Hey, by the way, is the music like too low, too high? I don't know what it sounds like for you guys. Let me know. Oh yeah. I should just be a struct. Okay, so if tokens is that, and let's just do tokens of that is under Y. We'll do that. And then when we're done, return our options. Or I guess I can do else if this, else. Actually, do I care? Something like that. I realize that when I drink my coffee with my left hand, you guys get to see this strange looking face here with this, the sunglasses. Okay, so I've got this way of loading an options file. And let's do this too. If we didn't find one, no options file found using default values. Okay. Let's do const auto options, we'll load our options file. And here, window X, if it's greater than or equal to 0, we want it. Otherwise, let's use centered. Oh no, not greater than or equal to 0, not equal to 0. Or, oh yeah, I can't you really use -1, can I? Huh, that sucks. So you know what? This is what we'll do. We'll just use the option as is. And if you don't specify it in the file, that means centered. Just keep it simple. Because in any case, yeah, this shouldn't be -1 then. Unless just thinking about whether we should just use standard option actually. Or is it optional? Like I did here with my breakpoints. In fact, if I don't do anything, it means it's not set. So this way, if we didn't set them, we'll know. How does this work again? I think I can do this. Basically, if the option was set, we read it, otherwise we say centered. Alvaro asks an off-topic question. Is Beyond Compare my default diff merge tool for Git? Yes, it is. It is, and I use Git extensions as my main UI, so it's actually configured in here. I forget where it's set. Here, Beyond Compare 4. So it sets up the path to merge tool, the merge tool command, that's for the merging, and then for the diff tool, it's the same thing, Beyond Compare 4. It's just set this way. So what does it not like? Oh, it's my split function? Oh, I didn't make this inline, did I? Because I don't need to make the template inline, but this is a non-template function here. No problem, Alvaro. You're thinking of using it as well? Okay. Let's put our breakpoint actually in run here. So in the output it should say no options file found using default values. In fact, a little bit more clear, we'll say no option file. Didn't get that right, there we go. Okay, and then if I use default values, it opens on the wrong side. But now we're going to see if this works. We'll save this. I gotta save it in the folder that it runs out of. So for me, that's gonna be Vectrexy. What's it run out of again? Does it run out of? No, that's it. It runs out of this root folder. So hopefully now it'll actually find it. Yeah, it found it. I realize I'm not in debug, so let me just switch to debug. So did that work? It did. Awesome. And let's see if this works. Nope. Huh. Did it? Window X. That's super strange. And then the next one, window Y. Oh, there's a space. Okay. I guess I don't handle that properly. So if I do space and tab and equals, maybe? No, that's not good. What I need to do, let me see my split how it works again. Yeah, it doesn't do any kind of like, that'd be a fun option. I think the split from C# has an option to say, what do you call it when you remove the white space around the tokens that it extracts after splitting? Like stripping or something? Yeah, that's it. It's got these string split options, right? Remove empty entries. That's not actually what I care about. Okay, so it doesn't even have the stripping that I want. Maybe I'm thinking of Python. But what do you call it again when you remove the white space around a string? Trim. Right, did I write a trim? I did not. I wrote a join and a split. So maybe it would be useful to have a little trim function. What did I just do? Oh. Okay. Yeah, I guess I can do something similar, but we'll put like by default something like that, and we'll say we don't need to loop in this case. So we'll just say start index equals starting from the beginning, and if start index is not equal to -1. Start index. Right. Then actually, is that right? Yeah, so we want to find the first that's not of those delimiters, and then we want to find that in reverse, right? Do they have that? Find last not of. And I think the offset is from the right side, so we'll see. I'll just call this index. And similarly, this time if it's not equal to -1, we want to do a substring of 0 to index -1, maybe. Okay, so let's see. Ideally, it would be nice to have that option in split where it would just trim all the results. That would be cleaner than trimming everything, right? Or what we can do is kind of have like a trim for a container of strings. Do it like this. should do standard just in case. Should I? Maybe not, no. And then we want to write that should get a standard string. And return the trimming of that string. Okay, so let's see if this works. So it compiles. All right, so we got our tokens. These are tokens that have spaces, one at the end of window X here and one at the beginning of the -700. I mean, we can like exacerbate this a little bit. If we come in here, put like a tab and a couple of spaces there, a couple of spaces and a tab, make a nice big mess. And now when we look at our tokens, we can see that, yeah, this guy's not so pretty. So let's see what trim does. Okay, so trim did not do the ending, but it did seem to trim the beginning. So something about my find last not of. So let's see, S, Windows X with a space and a tab, index 0. So maybe my find last not of this 0 here isn't actually what I thought. Oh, end pause. Guess that's what I need to pass in. No, okay. No, actually, I guess we do want to start from the beginning. What I don't. So what's wrong with this? Oh no, we want to find the last that is one of those. Yeah. Okay. As if we go from the beginning, basically. Okay. Okay, so let's see here. S is Windows X with a space and a tab at the end. That's not good. No, this is not right. I do want to do find last. Why was I checking -1? Actually, I should be checking npos, right? According to this, if it's not present, npos will be returned. Find the last character equal to none of the characters. So then what I want is, when I have that index, I want to remove from that index outward. So from 0 up to that index. So maybe this -1 isn't correct, but oops. So saying 0. Is it like is that 0 basically from the end? Is that what it means? Not quite understanding what this output means. Find the last characters that's not space or tab in this string here. So it should be the index of x, right? But I'm getting 0. Finds the last character equal to none of the characters in the given character sequence. The search considers only the intervals 0 to pause. Oh, it's because of the 0 here. Okay, yeah, of course. I'm searching up until 0. If I put nothing, it'll search till the end. Okay. Okay, now it's going to be fine. 6. Now let's see if my -1 is required. No. In fact, I might actually need +1 because it's the index of the last character. And in fact, doesn't substring want to count? Okay, so this is not even right. It's 0 to, yeah, index +1. So you write these once and then you don't look at them anymore. There we go, window X. So let's see. Do my values look clean? Window X and -700, that looks good. So now my tokens are window X -700. So it'll pick up on window X now. And it should pick up on window Y, yep. So my options have -700 and -1. And there we have it. And now if I remove this one here, it should be centered in Y. Yeah, there we go. Perfect. Let's do this. Trim of split of tokens on equal. That in my anonymous namespace. Okay, so now I have a way. I'm going to tweak this a little bit. Let's try minus 600. I don't need it to be like this. Kind of want it to be on the edge, so let's say 610. Okay, that looks perfect. And now, if I do this, there we go. You can see the line rendering. So let's get that checked in. And I want to ignore this options file. I'm gonna add that to my ignore. So let's first let's modify the git ignore right away. So it's kind of nice using optional for exactly what it was intended, right? If it's not set, we know that it's never been set. Very nice to have that feature in C++, C++ 17. Don't have to mess around with Sentinel values and, you know, all that crap. Okay. This here, string helpers, add trim string helper. I'll say string helpers, add trim for strings and string containers. Here I'll say add support for an options file. With add option file loading with support for window X and window Y values. All right, so that's good. So now that we've got that, let's work on implementing timer 2 for game frame timing. timer 2 is simpler than timer 1. So I can get some my doc on that. Don't really have too much. Timer 2 is used as system time. Wait, recal waits until timer 2 reaches 0, then resets to 16-byte value stored at this, okay, which is set. So this is more about how the BIOS uses it. So if we go here to our VIA, so we have the interrupt flag for timer 1. So I have a bunch of code for timer 1, and I have a bunch of to-dos for timer 2. Let's look what I have for timer 2. Yeah, these will probably disappear. In fact, it seems I have them, but I don't use them at all, right? Timer 2 low, timer 2 high. They're initialized. I don't even return them. Yeah, these are going to disappear. And I have here a timers.h where I have an empty timer 2. So the info for timer 2 would be in here. Yeah, there we go. Timer 2 operation. Okay. Timer 2 operates as an interval timer in the one-shot mode or as a counter for counting negative pulses on the PB6 peripheral pin. So pretty sure we only use it in one-shot mode, right? Just like the other one. Only supports one shot, yeah. So we're gonna do something similar here. Like, I'm wondering how much I'm gonna push into a common base versus keeping them completely separate. We'll see. Selects between these two modes. Now this timer is comprised of a write-only low-order latch. Okay, so let me just call the set mode in the VIA here. Same thing, timer 2. And we'll say get the timer 2 mode. Need to add a timer 2. Okay. So that's to get the timer 2 mode. We set it in there. Similarly, we're going to have a get for the get mode here, right? No? Oh no, sorry, timer mode. Okay, yeah, so I actually have some code I wrote in anticipation of this. That's for setting the bits when we return the auxiliary control. And then I think that's it for timer mode. Yeah. See, here we go. Here we go. Timer 2 is assumed always in one shot. I mean, it's possible that there's a ROM that changes that, and when if we hit that, we'll have the assert, and I'll go ahead and implement these other modes, but I don't expect that to be common. One thing that's weird is, why did I go for set mode and then timer mode? This should have been set timer mode. So let's fix that now. Same thing here. There we go. Set timer mode, set timer mode. So that's the timer mode. Next. This timer is comprised of a write-only low-order latch, a read-only low-order counter, and a read-write high-order counter. Really? The counter register acts as a 16-bit counter which decrements at 0 to rate. Figure 17 illustrates the T2 latch counter registers. Okay. Basically what it's saying is the only latch, the only thing that we need to that gets stored is for the low order, I think. Yeah. Yes, because then when you start the timer, you have to write to the high, and it just uses the value that was previously saved here plus this value to figure out the timer value. So that's similar actually to it's similar to timer 1, except timer 1 actually has a high order latch, right? Yeah, because in this one you can set up the latch so that when the timer expires it will reload the value in the low and high, whereas for timer 2 it doesn't support that. It doesn't have this like auto reload mode. That's basically the difference in the timer modes. Free running, which is what timer 1 supports, is this kind of like, I will reload the 16-bit value you stored in my latch in free running mode. Whereas timer 2 only supports one-shot and pulse counting, and pulse counting is not a reload thing, so it doesn't have that kind of high latch. So let's start coding that up. So some similarities here. We'll want a write counter low. We'll want a write counter high, but that doesn't store into the latch value. So we'll see about the rest of this. And we're going to want a write counter low, no, write latch low, which we'll just call write counter low similarly. And we won't have a write latch high because that doesn't exist. Now, okay, so T2 low order latch counter. 8 bits are loaded into T2 low order latch. So that's what we're doing. We store into the latch. And if we read 8 bits from T2 low order counter transferred to MPU, T2 interrupt flag is reset. Ah. So that's different. In both cases here, we actually reset the T2 interrupt flag, which was not the case. Oh no, it was the case. It's exactly the same for reading. So you read counter low, we'll do that. We're going to need our interrupt flag bool here. We'll need a counter. I'll just put a little note here. Note, timer 2 has no high order latch. Okay. Now if we write to the T high counter, 8 bits loaded into T2 high order counter, also low order latch is transferred to the low order counter. In addition, the T2 interrupt flag is reset. So that's pretty much similar to here, except instead of latch high, we'll just say take the value, shift to left 8, which will transfers contents of, so this is of counter high to counter and reset interrupt. So actually of counter high and low order latch. T2 counter and reset interrupt flag, which is what we're doing here. And if we read from counter, the high order counter, 8 bits from that is transferred to MPU, so that should be the same as read high here. Correct. There is no PB7 flag here, so all of this is going to disappear. Okay, so one-shot mode, that's what we're doing. As an interval timer, T2 operates in the one-shot mode, similar to timer 1. In this mode, T2 provides a single interrupt for each write T2 counter high operation. After timing out, the counter will continue to decrement. However, setting of the interrupt flag is disabled after initial timeout. Oh, that's interesting. So it will not be set by the counter decrementing again through 0. Right. That's not that interesting. Now the processor must rewrite T2 counter high to enable setting of the interrupt flag. The interrupt flag is cleared by reading T2 counter low or by writing to T2 counter high. Right. Timing for this operation is shown in figure 18. So this is similar. We write here one cycle, well, or yeah, this is like a 1.5 cycle passes, at which point the T2 counter high has gone yeah, so this is set, and then the IRQ output so the IRQ output remains high and then goes low when the timer has run out. So let me see here. Is that same thing as this? Yeah, it goes low once the timer has expired. And then when does this get set to high? To true. So yeah, upon writing to the okay, so I mean, I guess it's similar. Okay, so we'll want a it's not PB7 though in my case, it's interrupt signal, that's what I want. So we have an interrupt signal low equals to false, becomes true in there, yeah, I don't even think I'm reading the interrupt signal at all. Yeah, I don't even expose it. I think we only care about the flag. So, I mean, I'll put it in there because the docs talk about it, but I don't think it's that important. And in fact, I have no code that even resets it back to false after it's been set to true, so it's not quite. You know what? Until I have this correct, I'm just gonna forget about it. Yeah, exactly. I actually have a to do here. When do we set this back to false? What is it used for? So I'm not going to bother adding it yet to timer 2 because I don't think we need it yet. We just want the interrupt flag. And I do need that update function. And we'll need the set interrupt flag and all that. Okay, so I think that's all we need for timer 2. So now let's hook it up to our VIA chip. So yeah, I'm going to do this. All these nice little to-dos I did exactly for this reason. So we have the ability to write counter low and write counter high. I actually think the latch low was not even exposed because it's the same thing as counter low, right? Let's take a look. Zero 08. Via timer to count latch register low. Okay, so it's really the same thing. So technically, I never call write latch low, so we can just get rid of it. Timer 2. Gonna get rid of this. So here we are going to return timer 2 read counter low. Zero 08 and 09 should read those values. So here we're going to be able to finally set this guy here. So here, hack. For now, timer 2 will always report that its interrupt flag is set. This will make the game run faster. So now we can remove this hack, assuming my implementation works. And we're going to set the interrupt flag based on the value there. So this value is going to get queried basically in the BIOS, as I wrote here. If we go to wait recal, okay, so wait for the T2, the refresh timer, to time out, then restart it using the value in C83D, then recalibrate. So here we should have a little loop. Here, wait for timer 2. So you see how it's going? It loads 20, hex 20 into register A. Now hex 20 is basically setting bit 3, 4, bit 5, and it's going to check in the interrupt flag for bit 5 to be set. So if we go look at the interrupt flag register, which is here, this here should correspond to bit 5, exactly. So it's checking for that bit to be set. So it's going to be exactly equal, it's going to be set to 1 once our interrupt flag is set in timer 2, which happens when our counter expires. And then once it, so this here, this it'll say bit A branch if equal back to here, so it'll just keep doing this. And then once it's been done, then it comes down here to set refresh, where it loads a value from this memory cell, C83D, and says, okay, take that and store that into the timer 2 low, and then it jumps to recalibrate. So here, this should set a value there. In fact, it should be 30,000 decimal. That's how many cycles the Vectrex wants to be able to hit 50 Hertz. And then in recalibrate, I believe it's going to write to timer too high. Or not. Oh, store D. Okay, so actually this will do a double write to T2 low and to T2 high, which are actually consecutive. Like if we look at the memory map again, or if we just look here, T2 low is followed by T2 high. So it writes at 2 bytes. So in fact, by doing that, it'll write low and then write to high and reset the timer. It'll start the timer all over again upon writing to high. So there you go. So that should take care of getting it to run at 50 Hertz. How will I know? That's a good question. So just to make sure this is actually doing what I think it's doing, let's put a breakpoint on F19E to see that we are going to be waiting until enough until enough times this has happened. So let's see. Breakpoint there. Oh no. Disable, no, delete, remove 0, is it? Disable, delete 0. Yeah. Breakpoint at there. We've hit our breakpoint. And so we're going to keep running here until F1A2. So break at F1A2. Okay, so I think now we're just going to keep hitting the first one. So info break. So let's disable 0. So I want to see here. I'm doing bit A against the timer. Ah, you know what? I did forget to update the timer, right? Yes. I need to do timer 2 update cycles here. So once again, so you know what, let me set up what I usually do, which is set up my input. We want to break there, and we want to break here at the set refresh. And we'll do our usual load symbols. Okay, so we've hit our breakpoint, and now I'll disable 0. Boom. So this means that the timer just expired. So now if I enable 0 again, we should run until the next time we hit that breakpoint. There it is. Let's disable it. And once again, let's continue. And in fact, we can see on the right side here that it actually was able to render for 1 frame. So that's very interesting. So why don't we disable the trace, disable both our breakpoints. Oh, look at that. We can kind of see. Here, let's start again. And this time let's run in release. Trace. Okay, so I thought we might see something, but like maybe some movement. We do see some extra stuff appear a bit later, which I believe is like, there we go. You see that should say like Mindstorm, because ostensibly enough time has elapsed for Mindstorm to show. So there's a good chance that our timing code is working. Maybe as just a super quick test. I don't know if that'll work, but I'm thinking of just as a little hack, like in our render display here, let's try something. Let's do it up here. We have our delta time, right? Static double elapsed plus equals delta time. That's in seconds, right? If the elapsed is greater than or equal to 1 second, let's take the vias lines and clear them. And let's also clear our display. Oh, I can't do that here. Okay, so you know what we'll do? We'll just make this a data member. If m underscore elapsed, just want to try once a second to see what that gives, and then I'll actually make it 50 Hertz and see what that gives. Oh, and I need to also reset the elapsed here to 0. Oh, that's very interesting what we're seeing there. Okay, so let's try and get it more at 50 Hertz now, right? 1/50. This is not accurate, right? But this will give us an idea. Look at that. That should say Mindstorm or something. And then that shows, or is that Mindstorm? Very cool. Let's see. Let's see if I can find a video, the intro to Mindstorm. Okay, so like it'll be something like okay, so my timing is not exactly accurate, but so that would say apparently Mindstorm. I think what's happening here is you might have hit start. Player 1. And it's possible that if there's no input, maybe it just hangs there. I'd have to grab my Vectrex and try it. But it's very interesting. We're getting really close. Okay, so let's check in the timer code because I think it's pretty good. So via implement timer 2 used for game timing, game clock or whatever. Let's actually put this in hack clear and refresh. Clear lines and screen at approximately 50 Hertz. And this, I'll move down here. So I think it's pretty cool to see these lines moving and stuff. And you can see like the top line and bottom line appear, which would be for writing Vectrex, right? So here I'll say quick hack to clear lines and display at approximately 50 Hertz. I'm going to push this. So we're done this. So now we're going to work on this black overlay quad. So I'm going to be right back. I'm just going to go to the washroom. So I'll be back shortly. All right. Okay, so let's work on drawing this black overlay. See if that does anything interesting for us. I'm gonna hack it in OpenGL first, and then we'll see about putting it in properly. Yeah. So instead of doing this, I wanted to read something about GL clear. Just give me a sec. Let's see if GL clear, it has an alpha value, and I wonder, what does it do? Oh no, sorry, clear color. Like if we do a clear and set the alpha, would that do the trick? Curious. That's true, I don't have OpenGL functions. What was it again? gl.h. Maybe it's just easier to go through clear. I don't think this will make any difference. Okay, well that's what we know what it means, but what about for clearing? It says the color and alpha value in RGB framework will be cleared to width would be taken into account with destination alpha or 1 minus destination alpha blend functions, right? However, a regular on-screen window frame buffer usually doesn't carry an alpha. Okay, so forget this. This is not going to work. So I do wonder why I can't actually do OpenGL in here though. Doesn't like that I've got the GL clear here. Ah, yes, this again. Okay. So we want just wondering if I can construct an array on the fly. Never mind. So I need to do this. How does this work again? Yeah, it's from yeah, I don't know what my window width is. No, it's it. It's the Vectrex width and all that, right? So that's what we care about. 256 by 256. So it's so from there to there to there and to like that. And actually, okay, so not quite. I think I do need to set the blend func. I always forget how to set this up. Is it like 1 minus source alpha, 1 minus destination alpha? No, sorry, 1 minus source and then destination. Okay, we need to do GL enable for blend. Then we want to do GL blend func. I think it's GL1, like we leave the source alone, and then the target is 1 minus source alpha, I think. Or not. In the table and in the subsequent equations, first source, second source, and destination color components are referred to as so 0, 1, and D respectively. Actually, I think I know what's happening here. Unless, do I set the color in drawline? Ah, I don't. I should. I need to play with colors a bit. Okay, so let's set the color to white here. Aha. So we see our picture. So now let's mess around with alpha and see if that makes some difference. Oh, that's interesting. See, it's looking a bit more like what I imagined. Okay, that's too much. That's probably too little. Let's start all over, 0.001. Fascinating. So let's see if we can think about the right way to do the computation here. If there is such a thing. So like, let's say it would take 1 second for the thing to fade to black. So like a line is drawn and it would take 1 second. So what we would want is we'd want to be adding black for 1 second linearly, which would mean that the alpha would basically be like 1 second divided by Okay, so let's think here. So I'm getting like, let's say I got this 5 times. So that's it. I would want to use the delta time divided by this number of seconds. I mean, sorry, I would want to use, yeah, the actual delta time. So it's delta time divided by time to black, basically. That's going to be what my alpha is. So like, in the case of 1 second, I got a 0.2, it's 0.2 divided by 1, so it's 0.2. And this would happen for 5 frames, and we would be at black because we'd keep adding black at 0.2. But if I wanted to go like take 2 times as long, then it would be 0.2 would become 0.1, and I'd have to do it twice as long. Yeah, so that makes sense. So let's do something like now I doubt that it's going to take 1 second to go to black, but let's start with that for now. And let's compute alpha as delta time over that. So that's the thing, my render doesn't get the delta time, and it probably should, because it's being called every frame. So let's change this to get the delta time and the display. Okay, now we'll go into STL engine to our call to render, and we'll pass here the, where is it? Oh, I guess I'm gonna have to do this after we do our delta time computation. Actually, I should probably do it this way, right? Update, then called render. That actually makes more sense. Not render first. And we'll pass here the delta time. Mm-hmm. All right, so my time to black is definitely not right. I mean, it's probably going to take, how long, I wonder how long a beam lasts on screen. Probably, let's say it's 50 hertz. Interesting. Try different values. Okay, that's definitely no good. Let's try 30 hertz. Maybe. No, that's not clearing fast enough. I mean, the thing is, it'll never look quite right because I'm doing it like I'm doing it to the full screen, which is not correct. What I need to be doing this is at the pixel level. Each pixel that gets written got written at some time. This is pretty good though. This is good enough. So yeah, so what I was saying is, you know, the beam is moving and it's drawing, and there's, you know, it's not like it, you know, all lines that got drawn in one frame will last exactly the same amount of time, which is what I'm doing now. It's like I'm assuming that within one frame, all lines got drawn, and that's it. And also, we don't know when this render call gets, you know, it's not like we don't call render after the game timer has elapsed, so we know that a full screen has been drawn. This render call will happen many times in between, so it's basically we will be fading to black some lines that, let's say for a full image display, let's just imagine that we start drawing an object and then the render gets called and we start fading that one to black, and then we finish drawing the object on the next next frame, and then we fade it black again. So that's why we kind of get this like this effect of all kinds of sections kind of going dark and light. It's not quite being done correctly. What I need to do, and what I will be doing eventually, is writing into a buffer as I draw lines, and then I will pass through that buffer and bring down the values of each pixel. So I'll know when the pixel was written, like at what cycle it was written, and use that as a kind of like a time that it was written to value, and then bring those down all at the same time. And then what we'll do is that if you drew a line, let's say from left to right, the right part will fade out before the left part will fade out before the right. But this is decent for now. A decent approximation. Because now what I want to do is I really just want to fix the way this looks, right? So my suspicion that this is related to timing, and the way timer 1, which is used to draw these lines, although for the font I don't believe it's using timer 1. So yeah, I gotta look at timing and think about how to fix this. So let me see, how different is this result, let's say, compared to the hack that we had before? Oh, right. Gotta actually draw the lines. I'm not sure which one is technically better at this stage. This one's actually not that much better. I think I actually prefer it with my dumb clear lines display hack at approximately 50 Hertz here over the blending and all that I'm doing. I'm not really getting much out of doing it the current way. See that this looks like a bit cleaner. Okay, yeah, you know what? I'm gonna, just not to lose this work, I'm going to stash it, or maybe just make a branch for it. Although I do want to keep the fact that I'm passing delta time in there, because that's just useful. So let me selectively put that in there. Pass in delta time to render function. And I'll make a little branch here, and I'll say like hack fade screen to black. I like to create these little branches with work in progress commits, and I'll even push it just so that I have it backed up for if ever I want to look back at it. I'll push master as well. Okay, so now we're back to this. So my idea to fade the screen to black wasn't that awesome. All right. I'm gonna have to patch up that function there. Didn't quite do that correctly. Patch up my commit, I mean. Okay, you know what we'll do? We'll move elapsed into here. This way we're using delta time. Okay. All right. So let's amend this commit. Put this guy here. I'm gonna do an evil force push. And rebase here. All right. I caused a conflict in my own change. I prefer to do this now because if I want to cherry pick this later, I'm going to have to figure out that conflict, and right now it's fresh in my mind. So okay, and let's force push this as well. Back to master. Little git foo for the night. Okay, so I'm almost done for the night. I'm just gonna fix up. There's something I tried this on my laptop and I realized that it did not work. It works on this video card, but I do need to at least clear the rendering once before we go through. Oh no, sorry, on the display. At least once. This is required for certain graphics, or certain drivers or something. Like if we don't clear the buffers, the buffers may not have been initialized by the driver. And in my case, since I wasn't clearing them every single time, initially, I was having this problem on my, where I was not drawing at all until I had an initial clear. I mean, now we are calling clear at 50 Hertz, so it's not as important, but I prefer to do this like that. This won't really change anything. Okay. Get that in there as well. So I'll put here STL engine, make sure to clear display at least once for drivers that don't clear the clear buffers. Don't clear new render buffers. Okay. I think this is going to be it for tonight. So we didn't quite, this didn't quite do what we were hoping, but we still did it. And next is fix the drawing, which is ultimately what we're trying to get to. So now what we did tonight is we have the emulator actually running at the proper speed, ostensibly, right? Like this should be running at 50 Hertz in Vectrex time, that is. Simulating it that way. I mean, it's actually rendering at about 2000 frames per second, but the game clock and everything, the timing for cycles is supposed to be running close to the Vectrex if it's not exact. And we're clearing and all that. We're kind of simulating the 50 Hertz refresh rate here. And yeah, next it would be nice to actually fix the drawing of the fonts here. So we'll take a look at that in a couple of nights on Wednesday night if you're there. So those of you who watched tonight, thanks a lot. Alvaro, thanks for hanging out. And yeah, see you next time.